Hello, everybody. Today I'm going to be going through a crash course of the chain rule, which is one of the more daunting derivative rules in calculus, but I'm going to explain why it's actually really simple to understand in just a few short minutes. So the chain rule tells us how to find the derivative of functions in the form of f of g of x, which means you take some function g of x and stick it inside some other function f of x. An example of this kind of function would be like sine of x squared, where you're taking x squared and sticking it inside the sine function. And the chain rule tells us how to find the derivative of this kind of function. And I'm going to derive it for you just using basic principles of functions and derivatives. So we know that the derivative of any function, I'll label h of x, is just equal to the tiny change in the output, which is h of x, divided by the tiny change in input. By definition of a derivative, the derivative of any function is just a tiny change in the output divided by the tiny change in the input. So now I'm going to label a function diagram to show you what our function f of g of x is doing. What it's doing is it's using some function f, and f is taking g of x as inputs and spitting out f of g of x. That's what f of g of x does, because we know that h of x takes in h as inputs, so f of g of x takes in g of x as inputs and spits out f of g of x. All right. So as a result, if we know that the derivative of any function is equal to the tiny change in the function divided by the tiny change in the inputs, we can multiply both sides here by dx, and we get h prime of x times dx equals the tiny change to the function. All right, so this is the general equation. The derivative of h with respect to the input times the tiny change in the input is equal to a tiny change in the output. So all we have to do is translate this definition to our new function. All right, so our new function is f that takes in inputs g of x. So f prime of our input instead of x is now g of x, times the tiny change to our input, and our input is now g of x, so dg of x equals the tiny change to our output, f of g of x. And look, from this equation here, we know that the tiny change to any function is equal to the derivative of that function times the tiny change in its input. So we can rewrite dg of x, which is the tiny change in g with respect to x, using this equation right here, and I'm going to go to another page, by saying that this whole thing is now equal to f prime of g of x times g prime of x times dx equals the tiny change to the output, which is f of g of x. All right, now I'm going to divide both sides by dx. So this is going to go away, and this is going to become dx. All right, and let's look at the right side of the equation. What is it telling us? It's telling us that a tiny change in the output divided by a tiny change in x equals this. And what is this? This is by definition the derivative of f of g of x with respect to x. So then what's here is it tells us the derivative of f of g of x with respect to x. So this is the chain rule. It tells us that the derivative of f of g of x with respect to x equals f prime of g of x times g prime of x. All right, and we just derived that just by knowing the basic fundamental understanding of what a derivative is, and just by understanding what it is that functions do. They take in inputs, and spit out outputs. Just by knowing those two things, we can derive the chain rule. So I hope you guys leave this video having an intuitive understanding of what the chain rule is, and I will see you guys in another video.